Our understanding of space and time has just been shaken to its core. The James Webb Space Telescope has seen something that wasn't supposed to exist. Galaxies too old, planets too large, structures too perfect, and a signal steady, rhythmic, and unnatural that doesn't fit into any known astrophysical model. This isn't just another discovery. It's a collision between what we believed and what actually is. The James Webb Space Telescope may have just delivered the most profound warning and invitation in human history. And if what it has revealed is real, then everything we thought we knew about the universe is wrong. In a series of deep field observations, the James Webb Space Telescope captured some of the most detailed images of the universe ever seen. But beauty wasn't the only thing hidden in those pictures. In the galaxy cluster AEL 2744, researchers discovered perfectly aligned points of light symmetrical structures forming patterns that don't belong in the chaotic realm of galactic evolution. In the spiral galaxy NGC 1365, unusual motion patterns suggested gravitational behavior that directly contradicted our most basic models. And it didn't stop there. Similar anomalies began to appear across multiple images. The farther Webb looked, the stranger the universe became. Patterns repeated across billions of light years. Structures exhibited geometric precision in a cosmos that was assumed to be random. Scientists initially dismissed it all as coincidence, but there were too many patterns, too frequent, too perfect. And slowly, the whispers began. Maybe we're not seeing randomness at all, but a form of order we simply don't yet understand. Among Webb's many targets was an exoplanet named HIP 65426b, located hundreds of light years away. What it revealed left astronomers speechless. This planet is 7 times the mass of Jupiter, orbiting its star at 3 times the distance of Neptune, and it exists around a star barely 15 million years old. By all current theories of planetary formation, this planet shouldn't exist. There's no visible protoplanetary disk, no leftover material, and no gravitational explanation for how such a massive world could have formed so far out, so quickly, and remain stable. Some researchers have begun to speculate. What if this planet isn't a product of its current system at all? What if it's a remnant of a previous cycle, a relic from a star system that came before, somehow transplanted, reused, or even deliberately placed? For now, there are no answers, only a planet glowing at over 1000 degrees, suspended in a system that shouldn't have had time to build it. One of the most surreal discoveries Webb made was the imaging of what's known as an Einstein ringer, gravitational lens effect caused by a massive foreground galaxy bending the light of a galaxy behind it. But the ring around galaxy J418 isn't just any lens, it's nearly perfect, a complete, uninterrupted circle of light with such mathematical symmetry that even the most experienced astrophysicists were stunned. For such a precise image to exist, the alignment between the two galaxies must be exact down to fractions of a degree across billions of light years. That's not just rare, it's statistically improbable on a cosmic scale. And while gravitational lensing is a well-documented phenomenon, the level of perfection in this case is raising more questions than it answers. Could it be a sign of deeper symmetry embedded in spacetime itself? A clue that the universe is not as chaotic as we've assumed, but instead governed by a geometry we've barely begun to perceive. No discovery, however, has rocked the scientific world quite like this. 1. The James Webb Space Telescope has identified massive, mature galaxies forming just 180 million years after the supposed Big Bang. That may sound like a long time, but in cosmic terms, it's virtually impossible. According to current models, galaxies shouldn't have had enough time to grow to these sizes, organize into spiral structures, or emit the brightness Webb has recorded. These galaxies are as large as the Milky Way, fully formed and stable at a time when the universe should still have been a chaotic sea of gas. This has left cosmologists scrambling for explanations. Because if these galaxies are as old as the data suggests, then our entire theory of how the universe began is collapsing. The Big Bang, long treated as the foundation of modern cosmology, may no longer hold. And as some researchers are now saying openly, we may be looking at a universe that had a history long before our beginning. In a region far from any major galaxy, Webb detected something completely unexpected: a gravitational lens effect in a patch of space where nothing visible exists, no stars, no galaxies, no black holes, yet the light from more distant galaxies bends, curves, and distorts as if something massive is hiding there. Astronomers tentatively attributed this to dark matter, a form of mass we can't see, but which exerts gravitational force. However, the precision and intensity of the lensing effect challenge even that explanation. The distortion is too strong, too localized. It doesn't behave like a diffused cloud of dark matter, but rather like an object or structure with defined mass, symmetry, and edges. Could it be a cluster of dark matter condensed into a shape we don't yet understand? Or is this gravitational echo the remnant of something older, something left behind? Some physicists are now quietly entertaining far more radical ideas, that this isn't dark matter at all, but evidence of something built, something ancient and invisible, still warping space in its silence. Among the telescope's most controversial findings is the detection of a massive intergalactic filament or stretch of galaxies and matter aligned so precisely that it forms a structure over 1 billion light-years long. Scientists have observed filaments before, part of the so-called cosmic web, but this one is different. Its alignment, density, and repeating voids make it resemble a grid, almost like a framework laid across the universe, while mainstream cosmology suggests these patterns result from gravitational attraction over billions of years. The symmetry here is hard to ignore. The galaxies follow parallel paths, the dark matter clumps at exact intervals. Even the redshift readings from this region show a wave-like regularity, as if the fabric of the cosmos in this zone was intentionally engineered. Some researchers urge caution, reminding us that the human brain is wired to find patterns, even where none exist. But others are beginning to suggest that if the universe had a builder, or if intelligence once shaped it, this might be where we'd start to see the fingerprints. As scientists continued to investigate gravitational anomalies, one proposal has moved from the fringe into serious consideration: that dark matter, long thought to be invisible and inert, might actually carry information. Not data in the digital sense, but something deeper, a kind of cosmic memory. In several Webb observations, galaxy clusters formed in arrangements that seemed to mirror earlier, more distant formations, almost like echoes, repeating across time and space. What if dark matter, instead of being random, actually preserves traces of past cosmic structures? What if, as the universe expands, this hidden matter retains gravitational imprints, shaping future galaxies based on old alignments? It's a concept that blurs the line between physics and philosophy, suggesting that the universe may not only have a beginning, but also a memory. And if that's true, then every spiral, every cluster, every void might be part of a design far older than we've ever imagined. Perhaps the most spine-chilling finding yet is one that few are willing to speak about. During a deep field scan in a void sector, the James Webb Telescope recorded a series of pulses, light fluctuations, too regular to be random, too faint to originate from any known star. These signals didn't match the frequencies of pulsars or quasars. They repeated at exact intervals, then vanished entirely. Initially, scientists suspected an error, a reflection, interference, perhaps a processing glitch. But after running the data through multiple independent systems, the pattern remained. The origin point showed no stellar mass, no nebula, no heat signature, just a steady flash, precisely timed, as if measured or intended. For now, NASA has declined to comment, but behind closed doors, researchers are asking a question that has echoed for decades. What if this is a message that meant to be received, but simply noticed? And if so, who or what was meant to see it? The James Webb Space Telescope was built to reveal the past, to peel back the layers of time and show us what the universe looked like billions of years ago, but in doing so, it may have revealed something even deeper, that we are not just observers of the cosmos, we are part of a system far older, more precise, and more deliberate than we ever imagined. Galaxies that shouldn't exist, planets that defy gravity, signals without sources, structures that mirror intelligence. This isn't random noise. This isn't just science fiction playing with our curiosity. These are data points, real, measurable, undeniable, that challenge the very fabric of our understanding. And if the patterns are real, if the pulses are deliberate, if the universe remembers, then we must confront the most unsettling possibility of all: we have never been alone. Not in time, not in space, not even in thought, because what James Webb may have just uncovered is not simply a map of the early universe. It may be a message left behind, or a system that was waiting for us to look deeper. And now that we have, the world may never see.